Welcome back. So this is section 1-2, data classification. All right, now, in the last lesson we talked about, a lot of different, basics. So, what is a population? What is a sample? What is a parameter? What is a statistic? A descriptive statistics versus inferential statistics. Today is all about, okay, once we get that data, once we've collected that data, how do we classify that data? How do we talk about that data? Okay, that is what we're going to be looking at today. So the first thing we have to talk about way we classify data. The big two ways that we can talk about data is say that they are either qualitative or quantitative. Is that data is either quantitative or qualitative. Qualitative data consists of attributes, labels, non-numerical entries. Non-numerical entries. Like if I asked you give me your 5 favorite movies, qualitative data. If I said, okay, give me the names of your siblings, qualitative data. Give me the types of pets that you have, qualitative data. Non-numerical. That's the way to think of it. Non-numerical. And obviously the opposite of that is quantitative data. That's numerical. Data consisting of numerical measurements or counts. I said, okay, how many siblings do you have? What is the average temperature of each day? The hours that you spend studying, the hours that you spend on your phone, the time, temperature, amounts of things, measurements, whatever that may be. If it's a numerical entry, you would consider that quantitative data. If it is non-numerical, then you would say that that is qualitative data. Like for example, if I flip a coin, the outputs of that are all either heads or tails, right? Qualitative data. Now, if I turn that into, okay, how many times did I get a head? That's quantitative data. Pulling a card out of a deck of cards, qualitative data. The outputs are all qualitative. King of Hearts, 10 of Diamonds, Ace of Spades, all qualitative. But if I turn that into, some data can be qualitative that you can turn into quantitative. Usually quantitative can't usually be turned into qualitative, but qualitative can usually be turned into quantitative if you turn it into, okay, how many times that thing happened. Okay, for example, the table shows sports-related head injuries treated in U.S. emergency rooms during a recent 5-year span for several sports. And we see this table over here. We got a bunch of different sports, and then we got head injuries treated in the emergency rooms. What's qualitative? Which data are qualitative? Yeah, data. That's not a grammatical error. The word data is actually plural. So which data are qualitative? So what is qualitative about this? What is qualitative in that table? What would you consider qualitative data? The type of sport, right? The type of the sport would be considered a qualitative piece of data. Right? Type of sport. Type of sport. Okay, what is quantitative then? The amount of head injuries, right? The amount of the head injuries. The amount of head injuries. Yeah, there's a lot for basketball. That seems like a lot. Right, soccer, football, yeah. Volleyball. How would you get a head injury? So it's like diving. Forget where the end is. Now, okay, so data can either be considered qualitative or quantitative. Okay? You get some data, you can either say that it is quantitative or qualitative. There are other classifications that we could have. This is separating aside from quantitative versus qualitative. These are different levels of measurement. Okay, we're going to have 4 different levels of measurement. The first 2 are nominal and ordinal. And quantitative and qualitative data can fit in there. You'll see how here in a second. Data at the nominal level of measurement are qualitative only. Nothing that is quantitative should be going in the nominal level of measurement. Nothing that is quantitative, so numerical measurements, would never be considered a nominal level of measurement, because nominal is basically just like name alone. Right? If you're not ranking them or anything like that, if your data is just a collection of things, then that would be considered nominal. Data at this level is just categorized using names, labels, or qualities. Just names, labels, qualities. No mathematical computations could be done at this level. You're just saying, okay, give me your 5 favorite movies. Did I ask you to rank them from 1 to 5? No. I just said, give me your 5 favorite movies. Or if I said, okay, tell me what classes you're taking this year. That is nominal level. I'm not ranking them. I'm not putting them in any sort of order. I'm just saying, tell me what classes you're taking. Or if I said, tell me the names of your siblings. That's nominal level. Tell me the names of your pets. Nominal level. Tell me the brand of car that you have. Nominal level. Just names, labels, or qualities. Nothing beyond that. No mathematical computations or rankings can be made at that level. Okay, the next level is the ordinal level. The ordinal level of measurement are qualitative or quantitative. Data at that level can be arranged in order, but differences between the data is not meaningful. Again, let me say that again. Data at the ordinal level of measurement are qualitative or quantitative. Data at this level can be arranged in order. That's the difference between ordinal and nominal. Okay, rank for me your 3 favorite movies. Okay, that's ordinal now. Now that I've put some sort of order to it, that's the ordinal level. That's the difference between nominal and ordinal. Tell me your class schedule. Okay, I've put some sort of order to it, right? First period, second period, third period, and so on. I've put some sort of order to it, so now it's jumped from nominal level to ordinal level, where nominal level would just be the classes that you're taking. Ordinal level would be, okay, give me the schedule that you go by. If I had said, give me the names of your siblings in terms of age, okay, that's ordinal level. Give me the names of your pets and how long you've had that pet, in terms of how long you've had that pet. Okay, that's ordinal level. So the difference between nominal to ordinal is now things can be arranged. Now it can be arranged, not just saying what they are, just now saying, okay, instead of what they are, now rank them. Give me some sort of order to it. Determine whether the data are nominal or ordinal. So we're going to look at the 2 tables here. First table here, top 5 U.S. occupations with the most job growth projected to 2024. All right, nominal or ordinal? Ordinal, because I'm ranking them, right? If I had said this, if I blanked this out, that turns it from ordinal back to nominal, right? I don't know necessarily whether this is the order at which they go by, but as soon as I rank them, okay, now it's ordinal. Once I rank them, then it turns ordinal. Movie genres. Nominal or ordinal? Nominal, obviously, right? Nominal. Because I'm not ranking that. I'm not saying, like, give me the 5 most popular movie genres. I'm just saying, what are the movie genres that we have here? So this would be our nominal, and this would be the ordinal. Okay. Think order for ordinal. Think name for nominal. That's what I think of, at least. All right, so we have the nominal, which is the most generic one that we could have, right? Not ranking them or anything. Mathematical computations are not even a thing. But then we jumped out to ordinal, still qualitative data, not necessarily quantitative yet. because we're sort of quantitative in that we're putting things in order, right? But now we get a little bit more intricate here. The next one is the interval level. Data at the interval level is where we keep getting a little bit more descriptive with our decisions and things like that. Data at the interval level of measurement are quantitative. So this is where it drops qualitative. Now we're strictly quantitative data. So only numerical entries at this point. No more qualitative entries. Only numerical entries, quantitative data. The data can be ordered, and you can calculate meaningful differences between the data. Calculate meaningful differences between the data. The weird part about this one is that last statement. At the interval level, a zero entry is simply representing a zero on the position on a scale. What does that mean? That basically, like, think about temperature. Think about temperature. Could I go below zero in terms of temperature? Of course you can, right? So it's not necessarily saying an amount of zero. It's just a zero on a scale where we can represent things below it and things above it, right? I think about, time. Think about like the years since the year 2000. Years since 2000. If I say 10 years since 2000, well, that's just a scale, right? That's just, okay, 10 years passed. Well, if I zero it, well, that's just the year 2000. It's on a scale. I could go above it, I could go below it. Doesn't really mean anything if I go above it or below it. It's just a zero on a scale. I like to think about the best representations I can get for that are time and temperature. At the interval level, a zero is simply a position on a scale. It's not saying zero of that thing, right? It's just a position on a scale. If I said, how many siblings do you have? How many siblings do you have? If you have zero siblings, you have zero siblings, right? You have zero of that thing, right? That wouldn't necessarily be considered interval. You actually have zero of that thing. Okay? So that wouldn't necessarily be interval. That actually moves to the next step, which is, sorry, did anybody still need that? Yeah. The next one, so amount of siblings that you have would actually be ratio level. The level of measurement, similar to data at the interval level, but with the added property that a zero entry is an inherent zero. What does that mean? That means that it's actually zero of that thing. Whatever it may be, it's actually zero. Here, a ratio of two data values can be formed, so one data value can be expressed as a multiple of another. Ratio, think about ratio is, 1 to the next, right? Think of it as almost like a fraction, where a fraction of that thing would be actually meaningful. I could say I have, one person has three times as amount of siblings as another. That makes sense. We can actually do that. And that makes it, that will actually give us more information. When those things like that make sense, well, then it would be ratio. Ratio of two data values can be formed so that one data value can be easily expressed as a multiple of another. Okay. So, again, the big difference between ratio and interval is the inherent zero. If the scale has an inherent zero, meaning zero actually means none of that thing, then you would say that it's at the ratio level. If zero is just a position on a scale, then we would say that's just at the interval level. And again, think of time and temperature for that. That's the best way to think about it. Okay, determine whether data are interval or ratio. I hate this because I'm a Red Sox fan. It says New York Yankees World Series victories. These are the years that they won the World Series. Would that be interval or ratio? Interval. This would be interval. Think time. It is interval, right? I like to think about it this way as well. Differences are meaningful here, right? Differences are meaningful. I can find the difference between two data pieces, right? 1923, 1927. I can say, okay, it's been 4 years since that. But if I try to find a ratio between 1927 and 1923, like if I took 1927 divided by 1923, that doesn't really make sense, right? That doesn't really give us any sort of new information. The intervals between the pieces of data will give us information, but the ratios of them, like if I try to jump it, here, but if I tried to make it a ratio level, like if I tried to see if I took one divided by the next, does that tell us anything? Can I express one as a multiple of another? Not really, right? That doesn't really tell us anything new, and I can't really do that. In contrast to that, we got 2016 American League home run totals by team. Looks like the Orioles had the most. That's surprising. 2016 American League home run totals. That would turn into the ratio level, right? Because what am I looking at here? I'm looking at amount of home runs. Does 0 amount of home runs actually mean 0 home runs? Yes, that is an inherent 0. That's what I mean by the ratio level. Okay, and I could also think about expressing one as multiples of the other. Like for example, here, I could tell differences in between the two, right? I could still consider this interval level, like this American League home runs. Yeah, it has some properties of the interval level where I can say, Boston had 40 more home runs than Chicago, right? That makes sense. Differences in between the two still make sense, but also multiples of one to the next also make sense. Like I'm trying to find one that's like half, 250, 147. That's okay. But I could say, Kansas City, take Baltimore and Kansas City. If I took 253 and divided it by Kansas City, 147. Right? Okay. I know that Baltimore has 1.7 times as many home runs as Kansas City, right? I know that in terms of Baltimore to Kansas City, it's got a 171% or 172% increase, right? That actually tells us something. That actually is a meaningful statistic that we can use, right? Whereas if I tried to do that with the years over here, that doesn't really mean anything to us. It doesn't give us any information. Okay. The book presents this diagram here, and I really like it. So I'm going to show it to you guys. I've got the level of measurements listed down the side, and then the characteristics of those level of measurements along the top, because you got to think of it as like an umbrella. Okay, almost like if I call something a ratio level, it kind of has all the characteristics of everything above it. If I call something an interval level, it has the characteristics of ordinal and nominal, right? Okay, so put data into categories. Can I do that with nominal? Yeah, I can put it into categories. Yes, I can put it into categories. Can I do that with ordinal interval ratio? Yeah. What do I mean by that in terms of something with a ratio? Well, if I jump back to this table here, this one that we described, this ratio, can I put that into categories? Yeah, I could have, in terms of like, all teams that scored or that had between 140 to 160 home runs, right? I can put them into categories, almost like bands, almost, right? I could do that with interval level and ordinal level. Okay, but now if I jump to arrange the data in order, can I do that anymore with nominal? No, that's a characteristic that defines the ordinal level. I could still do that with the rest of the levels of measurement. Okay, if I classified something as a ratio level, I should still be able to arrange the data in order. Yeah, if I took that ratio level table of home runs, could I order it from least to greatest? Yeah, of course I could. I could put that in order. If I took that table of years of the Yankees wins and I put those in order in terms of time, of course you can. Yeah, I think that table was organized chronologically. So yeah, I can still put it in order. But then when I jump to the interval level, the subtract data values, okay, I can't do that with nominal. I can no longer do that with ordinal. I know it may seem like you might be able to, but you cannot subtract the data values anymore. Let me jump back to this. You might be thinking, wait, you ranked them. You ranked them. So can't I take 5 minus 1? Be careful with that. The actual entry is retail salespersons. Does it make sense to take retail salespersons minus personal care aides? No, that doesn't make sense. I can't subtract those two quantities. You may be thinking about ranking. I get what you're doing there, but in terms of the actual pieces of data, the piece of data is the retail salesperson, the personal care aide, the registered nurses. I rank them. I put them in order, right? Think of it in terms of like the schedule that you have per day, right? It wouldn't make sense to take 8th period minus 1st period, right? I know you would think that, that means that there's seven periods apart. Yeah, but it doesn't make sense to take English minus math, right? And then determine if one data value is a multiple of another. That's the key characteristic of the ratio level, and that's what separates it from interval level, right? You can no longer express one data value as a multiple of another, like the Yankees wins, right? I can't take, it's 1.7 times as many years. Maybe you could try to think about it in terms of the amount of years in between, but then I'm changing the actual data. The pieces of data here are the years of the Yankees wins, not the amount of time in between, just the singular years. So you could turn interval data into ratio level by describing it in a different way, but the years as they sit right there would only be considered interval. We would not move them to the ratio level because they're strictly just the years. It wouldn't make sense to create ratios and multiples of one another. And if I change the data, I might be able to, but as it sits right there, we wouldn't be able to. Okay. So what do I mean by this? Well, you got to remember that the ratio level has all the characteristics of all the levels above it, which kind of tells us as we move forward, what's the most descriptive level that we could have? The ratio level. So if we want to, maybe if we're creating a study or we're creating a survey or creating some sort of something that we're going to ask students, the best thing to use is something that we would consider ratio level. To be able to describe the data as best as possible, we would try to find something that is ratio level. Does that mean we would never do something that is ordinal? No, it just has a time and a place. But if we're going to be using data to create charts and graphs and things like that, the best thing to use would be something ratio. Okay, something at the ratio level. Nominal level, has its time and place. Ordinal level, has its time and place. Interval, same thing. Depends on what we're studying and what we're looking at. But if we're truly going to find something, truly angling ourselves to try to find something that we can describe really thoroughly, ratio level would be the best one to use. Okay. All right, that's all we got for today. Homework is here. Oh no, 6 problems. Oh no, so many. Let me shut off the video real quick.